Hi everyone. I already did this video, and this is a little addendum, and what I'm going to do is take the original video that I did and I'm going to attach 2 more videos to it at the end, which tells you how why these two equal, and just got little proof there. And I'm also going to attach this video to be more clear on why the integral secant cube of x dx equals, actually it should be 1/2 here. Should be 1/2 of this. I did a quick video on this that explains this portion of it, because both of these parts are going to show up when you evaluate the integral given. Thank you. Hi everyone, we're going to evaluate the given integral, and we're going to use our special integration of tan x and secant x in this problem. So these are good to know. The first thing we're going to do is just break this up a little bit. So for tan squared, I'm going to write this with my identity as secant squared x minus 1 times secant x dx. Now I'm going to distribute, and I get secant cube x dx. And then I'm going to go ahead and separate this out. So you multiply that, but I'm going to save some space and go ahead and split this up. All right. Now for secant cube, we're going to take this piece and integrate that by parts. So for that, we're going to let u equal secant x. Let's split this up a little further down. We're going to let u, so we're not going to deal with this piece right now. We're just going to deal with this piece. So we're going to have u equals secant x. Therefore, derivative of u equals secant x tan x dx. And we're going to let dv equals secant squared x, because I'm going to break this down as secant x times secant square x. All right, so my v is just going to be tan x. Now, we're going to use our integration by parts formula. So that's going to give me udv, so that's going to be secant x tan x minus the integral of secant x tan squared x dx. Now, if I integrate, well, this first part we just still have secant x tan x minus, and I'm going to factor out, I'm going to keep my secant x here and rewrite this as secant squared x minus 1 dx. So I'm going to break this up, and I'm going to get secant x tan x minus, now when you distribute that, you're going to get secant x cubed minus the integral of secant x dx. So basically, using our formulas here, and we're going to use, I should have a black here. Using this formula, what you're going to get is the integral of secant cube x dx equals 1/2 secant x tan x plus, and I'll move it down here. Let me just write it down here real quick. So it's going to be 1/2 secant x tan x plus ln of absolute value of secant x plus tan x plus c. So that part was for this first part we had. All right. And that's using our special formulas. Now, we're going to finish this up. We still have minus secant x. So we have this piece, and then we still had, so let's go back to what we had. We had this secant cube x dx minus integral secant x dx. So we know the antiderivative of this piece is here by integration by parts. And then for this piece, we're just going to use this again. So this piece is just going to be minus ln of secant x plus tan x plus c. So writing it all out, you will get 1/2 secant x tan x minus ln of absolute value of secant x, and I'm just grouping this together, plus tan x, close it up, plus c. And that's your final answer. Thank you. Have a nice day. Bye-bye. Hi, everyone. We're going to show that the integral secant x dx equals ln of the absolute value of secant x plus tan x plus c. And so it's kind of like an identity. And if you start from the right side and look at that, what you can do with that is to multiply secant x times secant x plus tan x divided by secant x plus tan x. So that equals 1. And then you still have your dx. So when you do that, you're going to get the integral of secant squared x plus secant x tan x divided by secant x plus tan x dx. Now, if you let u equal secant x plus tan x, then du is, you just take the derivative of each of those. So that's going to be secant x is secant x times tan x, and the derivative of tan of x is secant squared of x dx. So I'm running out of room here, so I'll just put the dx down here. So now we can substitute, and so this whole thing, the numerator equals dx, and the denominator, well, it's actually du. So let's put du, and the denominator is u. So when you integrate that, you're just going to get ln of u plus c. Then we plug back in our u, and so our final answer will be ln of secant x plus tan x absolute value plus c. Or you can go the other way. So if you're just trying to show it we can look at this right-hand side and just take the derivative of that. So you take the derivative of the right-hand side, you're going to get 1 divided by secant x plus tan x. So we're taking the derivative of this with respect to x times the derivative of this inner portion. So the derivative of secant x is just going to be secant x tan x. And the derivative of tan x is just secant squared of x. And then we have that all over our denominator, secant x plus tan x. Now, let's factor out a secant. You factor out a secant x, you're going to get tan x plus secant x, and divide that by our denominator, which is secant x plus tan x, and these two cancel, so we get back to our left-hand side of the equation. So either way is how you would show that. That's it. Thank you. Bye-bye. Hi, everyone. We're going to find the integral of secant cubed x dx, and we're going to use integration by parts. So the first thing I'm going to do is let's use our u substitution for integration by parts. And if I rewrite this, I'm going to rewrite this as secant x times secant x squared dx. So now when you do that, let's use our u, find our u in all this information. So we're going to let u equals secant x. Therefore, du equals secant x tan x dx. Then we're going to let dv equals secant squared x dx. Therefore, v, the antiderivative of secant squared, is tan x. Now I can use my formula. We're also going to use this formula here. This is going to show up. And so I'm going to attach the video that I already did on this at the end. But you need to know this formula here. So basically, let's get started and use our integration by parts. So we're going to get, for this is your u, and this is your dv, is everything else. So using the formula, we're going to get this equals secant x tan x minus secant x tan, I need to move this over. I'll fix that in a minute. So tan squared x dx. Okay, this was du right there. All right. Now, simplifying this further, we get this equals, I'm going to move down, secant x tan x minus the integral of secant x times, and I'm going to take my identity for tan squared of x, my Pythagorean identities, and write this as secant squared x minus 1 dx. All right, and then I'm going to distribute. So we still have this equals secant x tan x minus, now when I multiply these two, I'm going to get the integral of secant cubed x. And then I'm going to go ahead and put this in brackets, minus, when you distribute here, secant x, now put an integral in front of that. And this whole thing is dx. So I went ahead and did 2 steps. I distributed, and then I broke up the intervals. So this is going to end up being, and I'm going to rewrite it, when you distribute the negative, you're going to get secant x tan x. And again, this is for our integral of secant cube x dx. So minus our integral of secant cube x dx plus the integral of secant x dx. Now, we already know, so let's write this out. Minus this integral, equals secant x tan x. All right, then I'm just going to copy this part down. Integral secant cube x dx. And then I'm giving you this one. So if you take the antiderivative of secant x, you're going to get plus, I'll put it down here, ln of secant x plus tan x. And this is going to be plus c. Now the problem we have is this part right here. So what I'm going to do is I'm going to add it to both sides of the equation. So if I add it to this side, it'll go away, and I'm going to add it here. And that gives us 2 secant cube x dx equals secant x tan x plus ln of secant x plus tan x plus c. And then the only thing else we have to do, and I'm going to go ahead and just erase it here. I have this 2 here. So I'm going to divide both sides by 2. So that means I'm going to put a 1/2 here and just put it over the whole thing except for the C part. All right. Integrals like this one may seem special, but they occur frequently in applications of integration. So this one is a really good one to know. Thank you. Have a nice day. Bye-bye.